lesson 7-2, division properties of exponents. Here you can see a couple properties that we're going to be looking at: quotient of powers and power of a quotient. So you can use repeated multiplication and the principles of reducing fractions to simplify the quotients of monomials with the same base, like 2 raised to the 8th power divided by 2 to the 3rd power. First thing you need to do is first expand the numerator and then the denominator, and then divide the common factors. So here you can see they're expanding them, 2 to the 8th power, then 2 to the 3rd power. And then they divide out 2's, 3 of the 2's on top and 3 of the 2's on the bottom, and all you're left with is 2 times 2 times 2 times 2, 5 times, which will give us 32. So the quotient of powers says for any non-zero number a and any integer x and y, a to the x power divided by x to the y power would be the same thing as saying a to the x minus y. So when you divide like bases, you're going to subtract the exponents. When we multiplied like bases, we added the exponents. So multiplication and division are opposites, adding and subtracting are opposites. So when you divide like bases, you subtract the exponents. So here, these are some examples of quotient of a power property. You're just taking b to the 5th divided by b cubed, just subtracting them, and you get b squared. Either way, each method, you'll still get the same answer. You would use the method that you feel most comfortable using. So the quotient property, divide powers with the same base, subtract the exponents. So some examples. We're assuming that the denominator does not equal 0, because if the denominator equals 0, you couldn't solve that because you can never divide by 0. We're going to solve this in 2 steps. So step 1, group powers with the same base. So we're going to have b to the 5th minus 2, b to the 2nd power, and then we're going to have c7 minus c to the 1st. So then when I simplify it, my answers would be b to the 3rd, c to the 6th. Next, simplify this one. So we're going to group them. So 3 minus 1 times y, 7 minus 5 times z to the 1st. So when we write our answer would be x squared, y squared, z. Next, simplify this one. Again, we just group them, so we just have an a squared. This would be b to the 9th minus 8. We got c 1 minus 1, and we got d to the 4th minus 1. So if I simplify it, that stays a squared, b to the 1st, and I don't have to put the 1 there. c 1 minus 1 is 0. Anything to the 0 power is just 1. So I don't need to put a c there. And then it would be d cubed. The one that gives me a squared b d cubed would be letter A, or not letter A, letter D. Moving on to the next one, example 2, a word problem at sea level. There are about 10 to the 25th molecules in a cubic liter of air. In the stratosphere, about 30 kilometers above the Earth's surface, the same cubic meter of air has about 10 to the 23rd molecules. Approximately how many times as many molecules are there in a cubic liter of air at sea level as there are in the stratosphere? So we're comparing sea level to the stratosphere. So at sea level, it was 10 to the 25th. And at the stratosphere, we had about 10 to the 23rd. Again, we have like bases, so I take the base and then I subtract the exponents of 25 minus 23, would give us 10 squared, which would mean that this is 100 times more. Next, a human brain computes at a rate of about 10 to the 15th calculations per second. One computer-specific specifications show that it can compute at a rate of 10 to the 8th calculations per second. How many times as fast is the human brain? So we're doing the human compared to making calculations as the computer. So for the human, it is 10 to the 15th divided by the computer, which is 10 to the 8th. When we have like bases and we're dividing, we subtract the exponents. So this would give us 10 to the 7th power, and 10 to the 7th power would be 10 with 7 zeros. So that would be 10 million times as fast. Next, Canada's West Edmonton Mall claims to have the largest parking lot in the world with about 3 raised to the 9th power parking spaces. California's Glendale Galleria has about 3 to the 8th power, 8th parking spaces. Approximately how many times as many parking spaces are there at West Edmonton as there are at Glendale? So West Edmonton, that's 3 to the 9th, and Glendale, that's 3 to the 8th. Like bases, you subtract the exponents, so give us 3 to the 1st power, which will be 3. So 3 times as many parking spaces as the Glendale Galleria. Our next part is dealing with the power of a quotient. So power of a quotient means you have your base as a fraction and you're raising it to a power. Just like when you're going to raise something to a power, you raise everything, including the numerator and the denominator, to that same power. So here an example, 1/4 raised to the 5th power, you raise 1 to the 5th power, 4 to the 5th power, and that will give you 1. 4 to the 5th power would give us 1024. So it really would equal 1 to the 1024th power. So an example, simplify this one. So I need to raise everything. So 5 to the 3rd power, a squared to the 3rd power, divided by 6 to the 3rd power. So now I have 5 to the 3rd power, which is 125. A squared raised to the 3rd power is a to the 6th. Remember when you multiply like bases, or when you raise a power to a power, you multiply the exponents. And on the bottom, 6 to the 8th power, or 6 to the 3rd power would give us 216. So our answer would be 125 a to the 6th divided by 216. Next, simplify this one. I have to raise everything to the 2nd power. So that's 3 squared, x squared, z to the 4th squared, divided by 2 squared, y to the 3rd squared. So when I simplify it, 3 squared is 9, x squared, z to the 8th, all over 4 y to the 6th power. And this would be my final answer. I cannot simplify that any further. Next one, simplify this one. Here's multiple choice. So I know right off the bat it's not A because they didn't raise 5 to the 4th power or 7 to the 4th power. I know it's not D because they didn't raise 7 to the 4th power in the denominator. That leaves us with B and C. Now if I look at the exponents, 3 to the 4th, raise 3 to the 4th power, that would give us j to the 12th. The only one that has j to the 12th in here would be B. So our final answer would be 625 L to the 8th divided by 2,401 k to the 20th power. When it's multiple choice like that, it's quick just to scan the answers, the choices you have, and then find the ones that they did not simplify correctly. Example 4, assume that the power is 0 on this one. So I need to raise everything to the second power. So this would be x to the 8th power y squared all over x squared, y squared, z squared. Now here we still have common factors or common parts in the numerator and denominator. When you divide like bases, you subtract the exponents. And this z squared would just stay on the bottom. So now my answer would be x to the 6th, y would be 1. So y to the 0 power is just 1. And then I would have z squared on the bottom. So my answer would be x to the 6th, z squared on the bottom, or in the denominator. Next one. Here we're going to raise everything to the 3rd power, and then we're going to multiply by 2 at the end. So this would be 2 times a to the 12th, b to the 6th, c to the 3rd, all over a cubed, c to the 3rd. Now when I simplify it, c cubes divide out and become 1. And then I have 2 times a 12 minus 3 b to the 6th, which will give me a final answer of 2 a to the 9th b to the 6th. And our final problem. Simplify this one so that the denominator does not equal 0. So I have to raise everything to the 4th power. So it looks like with the numbers, they raised all the numbers. So 4 to the 4th power and 3 to the 4th power. So you can't look at that one. The variables, if they raise those to the 4th power, that would be m to the 8th, n to the 8th, p to the 8th, all over m to the 4th, p to the 4th. And when you simplify it, that would give you m to the 4th, n to the 8th, p to the 4th. And the one that gives us those numbers with 256 on top and 81 on the bottom would be letter B. Actually, I was misspoken. Not B, it would actually be C. They're very close, but if you look at the n, difference is n to the 8th. We need n to the 8th. B had n to the 6th. So the correct answer is C. So that is our lesson on division properties of exponents.